In this video, I am going to find the y-intercepts for each of these exponential functions, meaning that I am going to find the coordinates of each of these exponential functions y-intercepts. Let me start off with the first one. Y is equal to f of x is equal to 3 to the power x. If I sketch it, this is how it's going to look like. In essence, so this is 3 to the power x. In essence, what I am looking for is this point, the coordinates of this y-intercept. Remember, at y-intercept, x is equal to 0. So it's going to be y is equal to f of 0, meaning my x value is 0, is going to be 3 to the power 0. But 3 to the power 0 is 1. So the coordinates of this point is going to be 0, 1. This is an exponential growth since the base is bigger than 1. Now let's go ahead and do the other one, b, which is an exponential decay. By the way, you can write 3 to the power negative x as 1 over 3 to the power x, which is the same as 1/3 raised to the power x. This base is between 0 and 1, meaning that it's an exponential decay, and by the way, it's going to look like this. Okay? Now, as it turns out that both of these functions, so 3 to the power negative x, they intersect at the same point in the y-intercept. Now, we can do the same thing here. We want to find out f of 0 for this one is going to be 3 to the power negative 0, which is 3 to the power 0, which is just 1. So the y-intercept is going to be at 0, 1, the same thing, the same point. 0, 1. As it turns out, any function that has the form, if you have any function that has the form y is equal to a to the power x, its y-intercept is always going to be at 0, 1. Why is that the case? You have y of 0, that's what you are trying to find, means f of 0, right? The function evaluated at x equal to 0 is going to be a to the power 0. A is some base, okay? Any base where exponential function is defined. Just to remind you, a is always positive and a is not equal to 1. That's what the definition of exponential function requires base a to be. Now, a to the power 0, by the way, is going to be just 1. So, any function, exponential function that has this form y is equal to a to the power x, it's always going to go through the point 0, 1. So, this should be clear. Now, let's look at the other two problems. Now I'm going to look at C, which is y is equal to f of x is equal to 3 times e to the power x. So the difference between this function and just simple e to the power x is that it goes up 3 times as fast, okay? So it's even more steeper. So it's hard to see from a sketch, but I'm just going to sketch it right here. So this is how it's going to look like. 3 times e to the power x. This is 3 times faster than e to the power x. That means it's going up 3 times as quickly as e to the power x would. Now once again, if we want to evaluate this function at x equal to 0, meaning we are trying to find this y-intercept, all we are going to get is 3 times e to the power 0, which is going to be 3 times 1, because e to the power 0 is 1, which is just 3. So when my x is 0, my y is 3. So this point of intersection with the y-axis is at 0, 3. Similarly, we could do this one, D. Let me use a different color. It's going to be, let's use yellow. This is how it's going to look like if you sketch it. It goes through this point. Again, we are going to try to find the value of y when x equal to 0 is going to be negative 2 times e to the power 0, which is going to be negative 2 times 1 is going to be negative 2. So this point is going to be at 0, negative 2. So that's where the y-intercept is. In general, if you have a function y is equal to f of x is equal to a times b to the power x, it's an exponential function, its y-intercept is going to be at 0, whatever is the coefficient right here, a. Why is that the case? So let's find it out. When x equal to 0 is going to be a times b to the power 0, but b to the power 0 is going to be just 1, so a times 1 is just a. So that's why we have the y-intercept at 0 comma a. In general, this holds true. When you have something like this, f of x is equal to e to the power x, I told you that the y-intercept is going to be at 0 comma 1, which by the way conforms to this one, because if I compare this with this, what is my a? A is just 1, because e to the power x is 1 times e to the power x. So in essence it is 0 comma a, but a happens to be 1, and that's why we have it. So in general, if you have an exponential function that has the form a times b to the power x, 0 comma a is going to be your y-intercept. This is also sometimes called initial point or starting point, because many times in the exponential functions your x is equal to t, which means it represents time, and time begins at 0, meaning that initially what you had. If you are using exponential function for population, if your time is 0, that tells you what is the initial population. If you are using exponential function for bacterial growth, at time t is equal to 0, it tells you initially how many bacteria you have had. So this is why we kind of say that y-intercept is the starting point for many real-world applications for exponential functions. I hope that this discussion was helpful. Thank you very much.